Hello everyone. In the continuation of our previous two lectures, which focused on the concept of group and ring, in this session I am going to discuss the concept of field, which can be considered as the extension of the concept of ring. So let us try to understand that what exactly a field is. If you didn't watch the previous two sessions, which is on group and ring, try to check it out so that whatever terminology I am using in this session is clear to you. The first terminology that I discussed in the previous session is about the algebraic structure. So, algebraic structure is a structure which is having a non-empty set and with one or more than one binary operation. In group, we do have one binary operation. In ring, we do have two binary operation. In field, we do also have two binary operation. Let us consider them as plus and dot, or I can say plus and star. So we call this algebraic structure as a field. Many properties similar as ring. Some additional property comes when talking about field. Like in ring, we prove that the algebraic structure with respect to first operation must be a abelian group. So that is also true. That is a abelian group. So if we want to prove this structure is a field, the first thing we are supposed to do, prove it with respect to first operation, it is a field. Second is what? In the ring, we are supposed to prove with respect to star operation, it should be a semi-group. But over here, we are supposed to prove F star with second operation is also a abelian group, Now, do not make yourself confuse F star and star. This star is an operation. This star is a notation. Now, what is F star over here? Where F star is not original F, but it is F minus 0. 0 is what? The identity with respect to the first operation. Okay. So, now in the first part, we are proving F is a abelian group. In the second part, remove the additive identity from F and then prove that it is a abelian group. The third property is same as the distributive law. What it says that the first operation, the second operation is distributed on the first operation from both the side, from the left side as well as from the right side. So this is how we can understand the concept of a field. This is how we can understand the concept of a field. So this is what a distributive law is. So a structure is called as a field if with respect to first operation it is abelian group, with respect to second operation abelian group, but not the original F star. What is F star? F minus 0. What is 0 over here? Try to consider it as a identity with respect to first operation, not only solely as it is 0. Then the third one is what? The distribution or distributive law should be hold for second operation on the first operation. Let us take one example and that will make the things much clearer to you. So suppose that over here we do have a set F and operation is given as addition modulo 4 and multiplication modulo 4, where the elements of F is given as 0, 1, 2 and 3. Now we are supposed to check that this structure F is plus 4 and multiplication 4 is a field or not. In this scenario, what will be F star? F star will have the element as 1, 2, 3. That means F minus 0. Okay, so we are supposed to prove the first property which says that F with respect to addition modulo 4 is a abelian group. So abelian group means it will satisfy the phi property which is closer, associative, then existence of identity, existence of inverse, and the last one is commutative. Then we'll prove that this F star with respect to second operation is also a abelian group. Then the last one, we are supposed to prove that the operation multiplication modulo 4 is distributed over addition modulo 4 from both the sides. Okay. So A x4 plus B and A x4 plus C. It should be from both the side. I did only from one side. It should be from both the side also. So for checking these one by one, what we are supposed to do? We are supposed to make a Calais table or composition table. So let us make table firstly for plus 4. For plus 4, the element that should be taken as 0, 1, 2 and 3. As already discussed in the previous session that addition 4 is an operation, what it gives if somewhere it is written, so it means what? It gives you the remainder when A plus B is divided by 4, is divided by 4. In the same manner, if it is multiplication, so A multiplication 4 or A multiplication modulo 4B is the remainder when A cross B is divided by 4. So let us see what it gives you. So 0 is added, then 1, 2, 3. 3 plus 1 is 4 and 4 divided 4, the remainder is 0. 2, then 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5. 2 plus 3 is 5 divided by 4, remainder is 1. So 3, 3 plus 1, 4, 3 plus 2, 5 and 6. So this is the composition table, and over here as you can say that it is closure, it satisfies the closure property. How? Because every element in the table is there from set F. Associative, yes, we know trivially that addition modulo 4 is always associative. Third property, talking about identity element. So you can say identity element is 0 on it. 0 on it, why? Because 0 is the element when added to anywhere, that anyway any element is the output. Talking on inverse, since 0 is the identity, so just find out the 0 in each of the rows and that will help you to find the inverse. So inverse of 0 is 0. Yes, you can say inverse of 1 is 3. Just see 1 and 3 apply, it gives you 0. Inverse of 2 is 2. Inverse of 3 is 1. So now you can say for every element inverse exists. Then after inverse, commutative, yes, we know that the addition mod 4 is commutative. That means for every A and B, A plus 4B and B plus 4A is same. So what we did by using the Calais table, I prove all the 5 property. Hence, I can say A plus 4 is a abelian group. Now talking about F star cross 4 is also abelian group. So F star cross 4 is the operation. F star is having element 1, 2, 3. So we are supposed to make a composition table for F star. So for F star, we can make a composition table in the same manner and we'll check all the properties. And yes, it will comes out also as abelian group. And then finally, we will see that distributive law is hold as a trivially true. It is a trivially true that multiplication is always on always distributive on addition. Hence, I can say the third property is also true. So now all the 3 properties true. So the given structure is a field. I am leaving the second part for a practice for you, for exercise for you. Make a Calais table for this. And if there is any confusion, do let me know through comment box. If nothing is there, it's good. So that's all about for this session. Let us close this session.